So we've been looking at right triangles, and right triangles are great because if we're given two sides of the triangle, we can find the third side, which is unusual. We can't do that for other triangles unless we use more advanced forms of mathematics. For special right triangles, there are even better rules. So for special right triangles, what we can do is, given one side of the right triangle, we can find the other two. And that's just amazing. So first off, the first type of special right triangle we have is called a 45, 45, 90. We get that name based off the angles. So this is a 90-degree angle, and these are two 45-degree angles. This makes it an isosceles triangle, because these two angles are congruent. So this is a special right triangle that's also an isosceles triangle. So we know that whatever this leg is, this leg must be the same size. Well, what about the hypotenuse? Well, we know a squared plus b squared equals c squared. So let's set this up. So we get n squared plus n squared is equal to c squared. If I have two n squares, I just say 2n squared is equal to c squared. But I don't want to know what c squared is. I want to know what c is. So c is equal to the square root of 2n squared. The square root of n squared is just n. So we say that this is n times the square root of 2. So I don't know. Yeah, so here I have some examples. But so let's say I have a special right triangle, and this is 5 and 5. I can see it's isosceles, so I know this is a 45, 45, 90 right triangle. And because these two legs are 5, this hypotenuse must be 5 times square root of 2. If you wanted to, you could use Pythagorean Theorem, but as you're going through all these steps, it's already been worked out. It's that simple. So let's look at some examples here. So here, of course, make this a little bit more challenging. So this is a 45, 45, 90. So this is the one leg, and it's 5 root 3. So this leg here is going to be the same. So that's also 5 root 3. This is going to be v times the square root of 2. So v is 5 root 3. This is 5 root 3 times square root of 2. We combine these, and we get that u is equal to 5 times the square root of 6. Over here, we know that n is going to equal m. And we know that 8 is equal to n times root 2. So to find n, we know we must divide by root 2. So we get that n is equal to 8 over root 2, but we can't leave a square root in the denominator. So what we actually end up doing is multiplying it by root 2 over root 2. Because now in my denominator, I get root 2 times root 2, which is 2. And in my numerator, I have 8 root 2. But 8 divided by 2 here is 4. So I get n is equal to 4 root 2. So this is equal to 4 root 2, and this is equal to 4 root 2. So we could have irrational values as the legs. It's not just the hypotenuse, which is always something times root 2. So we may have to use a little bit of algebra, but the rule still applies. All right, now we have a 30, 60, 90 triangle. This is the other kind of special right triangle where we only need to know one of the sides of the right triangle to get the others. So if we have this triangle here, this is an equilateral triangle. Notice that all of these sides are congruent to each other. So if all the sides are congruent to each other, then that means that it's an equilateral triangle, and all these angles are equal to 60 degrees. What I can do now is I can take a line from here and draw it straight down. So now instead of this angle being 60 degrees, it's going to make a 30-degree angle, and that's our 30, 60, 90 right triangle. Well, this side here, this leg, this is now half of x, so it's x divided by 2. So then I just need to figure out what this side is. So I can use Pythagorean Theorem, so a squared plus b squared is equal to c squared. So I know that c squared, my hypotenuse in this case, is x, so that's x squared. I want to find what a is, so a squared, and I know that b is x over 2. So I get a squared plus x squared over 4 is equal to x squared. So a squared is equal to x squared minus x squared over 4. But this is going to be 4x squared over 4 because I need common denominators to subtract fractions. So I get 3x squared over 4 is equal to a squared. So when I take the square root to get a, I get square root of 3 times square root of x squared times square root of 4. So this is going to be x root 3 over 2. Yeah, sorry, I confused myself for a second. So this side is going to be x root 3 over 2. Now that's a lot to deal with. So what we like to do is we like to get rid of this fraction. And so we'll multiply this by 2. So keeping in mind that this short side, we say that this is equal to this short side is x over 2, and this longer side, we say that this is x root 3 over 2. But we don't like this fraction, so we multiply everything by 2. So this becomes x root 3, this becomes x, and this becomes 2x, just like this. So in a 30, 60, 90 triangle, the short side is n, the hypotenuse is 2n, and the long side that's not the hypotenuse is n times square root of 3. So if n is equal to 2, let's say, then this side would be 2, this side would be 4, and this would be 2 root 3. And again, you could use Pythagorean Theorem for this. You don't need to remember this, but by knowing this, it saves you time. And it's going to be important later on for trigonometry. So let's take a look at this. This is special right triangle. So I know this side, this is my longer side, which as I've said before, so that long side is n times square root of 3. So this is n times square root of 3. So I could write this out here. So 7 root 3 over 2 is equal to n root 3. So to find out what n is, I just divide both sides by root 3. Well, when I divide by root 3, that's the same as multiplying by 1 over root 3. So now, these roots cancel out, those roots cancel out, so I get 7 over 2 is equal to n. Well, n is the short side, so that means here y is equal to 7 over 2, and x is equal to 2 times n, so that means that x is going to be 7. Again, using that algebra to help us solve. Over here, the longer side we know is going to be n root 3. So we get that 5 root 3 is equal to n root 3. I can divide both sides by root 3. So I get 5 is equal to n. So this short side is n. So that equals 5. And this hypotenuse is 2 times n, which is 10. So that's what you need to do. So understand these special right triangles, these rules. You can use Pythagorean Theorem to solve your problems, but you don't need to. It's a little bit of unnecessary work.